This is Statistics, Week 8, Part 8, Population Proportion Problems. Example, a random sample of 25 statistics students was asked, have you smoked a cigarette in the past week? 6 students reported smoking within the past week. Use the +4 method to find a 95% confidence interval for the true proportion of statistics students who smoke. Our solution is this. 6 students out of 25 reported smoking within the past week. So x is 6 and n is 25. Because we're using the +4 method, we'll use x equals 6 plus 2, which is 8, and n equals 25 plus 4, which is 29. To calculate the confidence interval, you must find p prime, q prime, and the EBP as before. P prime is going to be 8 over 29, which is 0.276. This is the point estimate for the population proportion. Q prime is equal to 0.724. Since our confidence level is 0.95, z of 0.025 is going to be 1.96. Our EBP is going to be 1.96 multiplied by the square root of 0.276 times 0.724 over 29, which is 0.163, and this gives us a 95% confidence interval of 0.113 to 0.439. Here's a try-it exercise for you to apply what you've just learned. Stop the video, and when you're ready to check your solution, start it again. 8.12. Out of a random sample of 65 freshmen at State University, 31 students have declared a major. Use the +4 method to find a 96% confidence interval for the true proportion of freshmen at State University who've declared a major. Using the +4 method, we have x is 31 plus 2 equals 33, and n is 65 plus 4, which is 69. So p prime will be 33 over 69, or 0.478. Q prime will be 0.522. Since our confidence level is 96, that's an unfamiliar one, you'll have to calculate that by first computing alpha, then alpha over 2, which is 0.02, subtracting that to get the area on the left, which would be 0.98, and then using that with inverse norm to find that our z of 0.02 is 2.054. Our EBP will then be 2.054 times the square root of 0.478 times 0.522 over 69, or 0.124. This gives us a confidence interval between 0.354 and 0.602. So we say we are 96% confident that between 35.4 and 60.2% of all freshmen at State University have declared a major. Calculating the sample size for a desired margin of error. If researchers desired a specific margin of error, then they can use the error-bound formula to calculate the required sample size. If we rearrange that error-bound formula with a little bit of algebra, we will get n equals z sub alpha over 2 squared times p prime times q prime divided by the error bound for the population squared proportion. When using this method, it is important to note that if we do not know what the population proportion p prime is, or don't have the data to calculate it, then we will need to estimate it to give the maximum value for the product p prime q prime. The largest product will give us the largest value of n. One way to do this is to let p prime be 0.5 and q prime equal 0.5, so p prime times q prime is 0.25. Here's an example. Suppose a mobile phone company wants to estimate the current percentage of customers aged 50 plus who use text messaging on their cell phones. How many customers aged 50 plus should the company survey in order to be 90% confident that the estimated sample proportion is within 3 percentage points of the true population proportion of customers aged 50 plus who use text messaging on their cell phones? Here's our solution. From the problem, we know that EBP is 0.03, 3 percentage points, and z of alpha over 2 is going to be 1.645, as we've calculated before, because the confidence level is 90%. However, in order to find n, we need to estimate the sample proportion p prime. So, what we are going to do there is use the method we just suggested to say p prime times q prime is 0.5 times 0.5, which is 0.25. Then we'll simply calculate n as z squared, which is 1.645 squared, times p prime times q prime, 0.5 times 0.5, over the error bound squared, 0.3 squared, giving us 751.7. We round this value to the next higher value and get that the sample size should be 752 cell phone customers aged 50 plus in order to be confident within 90% that the estimated sample proportion is within 3 percentage points of the true population proportion of all customers aged 50 plus who use text messaging on their cell phones. Here's a try it example for you to work out. Stop the video, and then when you've completed your solution, start it again to see the solution. 8.14. Suppose an internet marketing company wants to determine the current percentage of customers who click on ads on their smartphones. How many customers should the company survey in order to be 90% confident that the estimated proportion is within 5 percentage points of the true population proportion of customers who click on ads on their smartphones? So, for this calculation, the EBP is 5 percentage points, or 0.05. Also, for the 90% confidence level, Z sub alpha over 2 is 1.65, or 1.645. As in the example, we're going to let P prime and Q prime be 0.5, so then N is going to be 1.645 squared multiplied by 0.5 times 0.5 divided by 0.5 squared, or 270.6. Therefore, the sample size should be 271 customers. This concludes our Week 8 lectures.